Hi, I'm Kathy Levinger. In this lesson we're going to look at the sine, cosine, and tangent of angles. Let's start with their definitions. The sine, cosine, and tangent are ratios of sides of a right triangle relative to one of the angles. And so what you'll see here is relative to angle B in a right triangle. Take a look for a minute at the triangle picture. Here's angle B. Relative to B, this side is called the adjacent leg. Adjacent means it touches it. This side is called the opposite leg to B, and the angled side, as you know, is called the hypotenuse. Well, relative to angle B, we have a ratio called the sine. The sine of angle B, abbreviated or written actually, SIN of B, is equal to the length of the opposite leg, here's the opposite leg, divided by the length of the hypotenuse. Second trigonometric ratio is called the cosine. We write that cos of B, cosine of B, and it's equal to the ratio of the adjacent leg to B divided by the length of the hypotenuse. The third trigonometric function we're going to work with is called the tangent. The tangent of angle B, written tan of B, is the ratio of the length of the side opposite, or the leg opposite B, divided by the length of the leg adjacent to B. Well, let's try out these definitions in the following example. For the triangle shown, write down the sine, cosine, and tangent of angle A and angle B. Well, let's look at how these might look for angle A. We want to write down the sine of A. The sine is the ratio opposite side over hypotenuse. Relative to angle A, the side opposite has length 8 and the hypotenuse length 10. So that's the sine of A. We should reduce our answer to 4/5. The cosine of angle A, here's angle A, is the ratio of the side adjacent to it over the hypotenuse. In this case, 6/10. Reduced, that would be 3/5. And third, tangent of angle A. Now the tangent ratio, here's angle A, is the ratio of the side opposite, the length of the side opposite, over the length of the side adjacent. In this case, that's 8/6, which reduces by a factor of 2 to 4/3. So here are the sine, cosine, and tangent of angle A. Let's write down the sine of B, and then the cosine and tangent of that. The sine ratio for an angle is the length of the side opposite the angle over the hypotenuse. In this case, 6/10. That reduces to 3/5. The cosine of angle B is the ratio of the length of the side adjacent to the angle over the hypotenuse. In this case, 8/10, which reduces to 4/5. The tangent of angle B is the ratio of the length of the side opposite the angle over the length of the side adjacent, or 6/8. That reduces to 3/4. So these ratios are the sine, cosine, and tangent of angle A, sine, cosine, and tangent of angle B. Well, I also want you to be able to evaluate sine, cosine, and tangent of given angles on your calculator. So let's try that. Using a calculator, we're going to evaluate each trig function, and we're going to round our answers to 4 decimal places where appropriate. Well, there's a couple of setup things that we need to do on our calculator before we're ready to begin. The first setup thing is to notice that these angles are in degrees. This is a degree symbol. Choose mode on your calculator, which is in the top row of buttons on the keypad, and the third option down, once you've chosen mode, says radian degree. Using your arrow key, go down to radian and to the right one and highlight degree. Push enter so that that item is darkened in, shaded in. Now our calculator is in degree mode. To get out without undoing what we've done, we can push second, quit, and we're ready to make a calculation. The second thing I want you to do is find the sine, cosine, and tangent buttons. They're sort of through the center of the keypad with the abbreviations SIN, COS, TAN. If we want the tangent of 45 degrees, we push the tangent button. Next to that, type the number 45. You don't need to choose a degree symbol because you put your calculator in degree mode. Let me zoom in one more time so you can see what I'm doing. Tangent of 45, I'm in degree mode. Push enter. That number is 1. Well, while we're here, I'll enter cosine 67 and see that decimal. And I'll enter sine of 21, close parentheses, enter. And I can see that decimal. These are the problems that we're working. Let's write those rounded to 4 decimal places on our paper. The tangent of 45 is exactly 1. The cosine of 67 is 0.3907 rounded. And the sine of 21 degrees is 0.3584 if you round to the 4th decimal place. Well, keeping that in mind, let's look at an application problem using some of these trig ratios. A right triangle is drawn below. What we want to do is find the length of the missing side, and the missing side is here, labeled A. Well, the pieces that are available to work with in my triangle are an angle, the side opposite, and the hypotenuse in the triangle. The particular trig function that fits with an angle, the side opposite, and the hypotenuse is the sine. The sine of an angle, let's call it angle B, is the ratio of the opposite side divided by the hypotenuse. Well, let's fill in what we know or what we're given in our triangle. We have the angle. Our angle is 34 degrees, so I have sine of 34 degrees. The length of the opposite side is A, that's the thing I'm looking for, but I know that the length of the hypotenuse is 12. To solve what I have on my paper for A, I can multiply each side of the equation by 12 to get 12 sine 34 degrees equals A. And now I'm going to use a calculator to find that number. On my keypad, I'll type 12, choose sine, and enter 34 because I know I'm in degree mode. Let me zoom in and show you how that looks. We're looking for 12 sine 34. That's 6.7103. Rounding to 1 decimal place, we could say that side A has length 6.7. Let's try another. Again, a right triangle is drawn. We want to find the length of a missing side, and what we see as labeled information in the triangle are an angle, the side opposite labeled B, the one we're looking for, and the side adjacent labeled 7 centimeters. Now, the particular trig function that works with an angle, the opposite and adjacent side is the tangent. We saw the tangent of an angle B was the ratio of the side opposite to or over the side adjacent. Let's fill in what we're given in our particular example. The angle is 16 degrees. The length of the opposite side I don't know, but it's labeled B. The length of the adjacent side is 7 centimeters. Now, solving this equation for B, I can multiply by 7 to get 7 tangent 16 degrees is B, and I'm going to use my calculator to find that number. On my calculator, I'll type 7 tangent 16 degrees in close parentheses, pushing enter, that's 2.0072 and so forth. We're going to write that B is approximately 2 centimeters because we are given units in our particular problem. Well, let's try another. Again, we have a right triangle, and we're interested in finding the length of a missing side. What we see labeled in our triangle are an angle 78 degrees, the adjacent side to that, 13, and the hypotenuse. Now, the particular trig function that involves an angle, the adjacent side, and the hypotenuse is the cosine. As a matter of fact, the cosine of some angle B is the ratio of the adjacent side over the hypotenuse. Well, again, let's fill in what we have. We have that B, the angle, is 78 degrees. The adjacent side has length 13, and the hypotenuse is the thing I'm looking for. Now, what I need to do with my equation is isolate x. That's going to require a couple of steps. As a first step, multiply each side of the equation by x. So we're going to multiply each side of the equation by x. That will give us x cosine 78 degrees equals 13, since the x's will simplify on the right-hand side. Now, to get x by itself, divide by the number cosine 78 degrees, and x will be 13 divided by cosine 78 degrees, and we'll get that number with the help of a calculator. So picking up our calculator, we want to find 13 divided by cosine of 78 degrees, close parentheses for the angle in the trig function. Enter, and that's 62.52654 and so forth. Let's round that to 62.5 and say that x is approximately 62.5. Well, in this lesson we've looked at the sine, cosine, and tangent of angles in a triangle. Be sure to work lots of exercises from your textbook for practice.